Okay, so I'm going to show you how to take this and convert it into a strand of DNA. Step number one, and there are instructions for this in Google Classroom, is that this is our key, and we're going to color these in according to the key. Once you've colored the 1, 2, 3, 4 adenine, thymine, cytosine, and guanine, those are the nitrogen bases which are part of a nucleotide, and we know nucleotides are the building blocks of DNA. You're going to take this key and you're going to color each one of these nucleotides. So each little section here is a nucleotide, and we're going to take them, build them up and build them together, put them together to make a DNA strand. So once you've got them colored, you're going to color them, cut them out. So here's my key. You can see adenine is yellow, so this would be an adenine nucleotide. And you can see I've cut all the dotted lines out, and so I've got very little spare. There's extra space. You can see these little lines here all go to the very edge. That's adenine, the blue one. This is cytosine. We have a green nucleotide. This will be guanine. And then we have thymine, the orange ones. So in DNA, we know it's a double strand, and we know it's made up of nucleotides. So I'm going to do the first side of the nucleotide, and I'm going to take thymine, the orange one, and it doesn't matter. It does not matter what order you do these in. In fact, because everybody's DNA is unique, the order of these nitrogen bases, these nucleotides, is unique to you. So I'm going to take them and I'm going to line up. You see here with my pen, I'm going to do as best I can to line up this part here and this part here. This represents a bond that's between deoxyribose, which is a sugar, and phosphate, which is a group part of the nucleotide. So if you do this right, it should go phosphate, sugar, phosphate, sugar. Let me take another one, and I'm going to line these up as best I can, like that. Right? You can see what I'm building here, and I'm going to take 8 of these. So there's another one. Let's put this one up here, like that. That's 6, 7, 8. Okay. So I've got this side of my DNA strand is made. I have here on this side 1, 2, 3, 4, 5, 6, 7, 8 nucleotides excuse me, that are joined together, and you can see here it goes phosphate, sugar, phosphate, sugar, phosphate, sugar, phosphate, sugar, phosphate. This is called the phosphate sugar backbone. Now you'll also notice that the nitrogen bases, there are only 4 in DNA. There are 4 nucleotides. There are 4 types of nucleotides. There's this one, which is cytosine. There's this one, which is adenine. There's this one, which is guanine. And then there's this one, which is thymine. Okay? So there are 4 different nucleotides. And you'll notice that each one of these nucleotides has got a specific shape. Not without good reason. Because on the other side, what shape will fit with adenine? If you notice, the complementary, that's like the opposite shape to adenine, is actually thymine. So I'm going to come up here, and those two are going to join together, just like that. Okay? Adenine can only ever have a thymine on the other side. And if you look here at guanine, I'm going to need this one to fit here. Now when I bring this one in, I've got to make sure that my phosphates and my sugars match up. Okay, so like that. So next, I'm going to need to take a adenine again, and I'm going to need to bring this one in here. Okay, just like that. And so what I'm doing here is something called complementary base pairing. That means that the shape of the bases has to complement or match each other, right? Which is why adenine here, my yellow one, can only ever base pair with thymine, and cytosine, the blue one, can only ever base pair with guanine. You can't do this, right? You cannot do, right, that, because they don't complement each other, they don't fit together. But I can take this thymine and put it right there with adenine. And then here, I know I'm going to need a guanine, like that. I'll try and make sure my phosphate sugar backbone works. And so here I'm going to need to put another thymine. And then I'm going to finish up with my guanine there. Okay, so now what I've done is I've built both sides of a DNA molecule. You've got the phosphate sugar backbone on this side, and you've got the phosphate sugar backbone on the other side. But I want you to notice something, and this is really important, because the phosphate sugar backbones are what we call, if you know the word parallel is when you've got two lines which are straight. These are referred to as anti-parallel. That doesn't mean they're not parallel, it means that they're parallel in the opposite direction. So this one, you can see the sugars are pointing in that direction. Over here, you can see the sugars are pointing in this direction. So the actual phosphate sugar backbones are what we call anti-parallel, but in the middle, we have complementary base pairing. Now, what happens between the two bases here is a bond called a hydrogen bond forms and holds the bases next to each other, and then this will twist to make the double helix shape that we understand, that we know DNA is. So that's how you assemble your DNA molecule in your notebook.